Okay, hello and welcome in to my channel. Greetings, everyone. I hope everyone is doing well. Again, this is a live stream for Math Help. So, if you're out there and you're watching and you happen to be having difficulty studying for math, maybe you can put your math problem in the chat and see if I can help you. In the meantime, I am going to be working on my board and continuing the discussion of graphing rational functions. So I went back and thought a little bit more about this subject after the stream yesterday. And a lot of these subjects, it's been many, many years since I've worked on any of it. So it's interesting adding a little bit of theory and also getting some practice. I was given this problem in the chat. So I guess I'm going to square it so I don't erase it and erase everything else and continue the discussion of rational functions, beginning with this function in particular. So I rearranged this and I put it in polynomial form just by combining these terms and putting them over the denominator, using a little bit of algebra essentially to find the horizontal asymptote. But really, I didn't have to do that because I went online and I found a form for the for rational functions in this form. So I'm going to go ahead and erase everything else besides that function so that I don't lose it. And I'm going to start there showing and practicing writing this form out. And then possibly going through. I really want to show the process of graphing one of these by hand in its entirety from start to finish. That was my goal with rational functions. Back when I taught rational functions or I presented this topic, it was for a community college, but I was only limited to maybe a day. We were only allowed to spend a day on this topic. And I was just thinking, it's one of the nice things about just having the ability to present on my board is having the freedom of not having, and most of my students were really bored by this subject. And oh man, it really kills your energy when you have a room full of people that are just getting drugged through it. And, I actually enjoy sketching these graphs. So it's nice to be able to just work and not have to worry about what I'm, any kind of time constraints for sure. All right, so this form that I found for rational functions, we'll start there. So you got y equals a over h minus k. Yeah, x minus h plus k. Hang on. Mess it up. X minus h plus k. Make sure I wrote this correctly. And it gives you the function notation. So it's saying the absolute value of a is your vertical stretch. And it's tough to say if I never knew about the form or if it's just been so many years and I was introduced to it and I didn't see the relevance. There's a lot of things. If A is less than 0, that's going to lead to negative values, and that's a reflection. So about the x-axis. So you'll say x-axis reflection. And it says K is the vertical translation, or rather the K is your horizontal asymptote. I thought it told me, yeah, K is, well, it's a vertical translation, but it's also your, so I'll say shift because you're going up and down. It's a vertical shift, and it's also your horizontal asymptote. And yesterday I was spelling asymptotes wrong. It might have been just that my nerves, I don't know. I have a weird sense of my personality is weird. So sometimes I will get nervous and I'll just get in a hurry and skip my subjects are definitely not English. All right. Okay, so we've got vertical shift, horizontal asymptote. We have H is your horizontal translation here. So I'm going to say horizontal shift because what it's doing is it's translating it, it's moving it from the left to the right. So H. All right, H is your horizontal shift. And then it talks about the range and the domain. You have a vertical asymptote. So your vertical vertical asymptote is when, so yeah, x such that x cannot equal h. Okay, so that's pretty cool. I found this form and I thought we'll go ahead and just practice with the function and see if I can't sketch the graph of it real quick. Let's see. And we'll get a big clean graph. Sketch our Cartesian coordinate system here. X, Y. And so the first value we'll look at is, so A, there's no vertical stretch because it's just a 1. There's no x-axis reflection because it's positive. There's, here, let me get my table ready. And remember, we'll go ahead and start with that 1 over x. So we'll start with y equals 1 over x here. And then we'll kill 2 birds with 1 stone. I know that that's not a nice figure of speech, but it's effective here because what I can do is I can show you a clean example of how you would manipulate the points on your table at the same time as I can sketch the graph. So we'll start with the x values that we want to evaluate. And I think yesterday we went through -4. So let's see how far we'll go. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, Okay, so that'll be good for now. And recall, we'll start from our leftmost point and we'll say -5. Let's see, -4, -3, -2, -1. And then we're going to stop. We'll say -1/2, -1/4, -1/4. And we'll stop there. All right, so 1 over x is going to be 1 over negative. So we'll just go in here and list our reciprocals. -1/4, -1/3, -1/2, -1. And then here you're going to jump up to -2. And I'll go ahead and show the math on one of these just so you see what's going on. But when you plug in your function for x here, -1/2, you end up with 1 divided by -1/2, which is okay. -1/2, that's 1 over 1. And then what you do when you have to divide fractions is you have to invert that denominator. So that becomes -2 over 1, which in essence will become -2. So I did that for 1, but we're going to just repeat that process for the rest of them. And to get nice symmetry, we can go ahead and put -1/5 in here. So -1/3 is going to be -3. -1/4 is -4. And -1/5 is going to be -5. All right. And then recall our horizontal and vertical asymptotes. So HA, since the denominator is 1 less than the numerator is 1 less than the denominator, then you have a horizontal at y = 0. And then x can't be 0, so your VA is at x = 0. So your origin is essentially your horizontal and your vertical asymptote. So you have a graph that's bending and stretching towards the origin, essentially. So we'll start out at -5. We're going to -5, -1/5. And we're going to have to split this one up a little bit. So we'll say 1, 2, 3, 4. No. -1/5, -1/4, -1/3, -1/2, -1/4, -1/3, -1/2, and then -1. So we're going to make that a little bit more accurate because this looks like -1/2. So we're going to need another value in there. We'll say that's -1/5. And again, it's an accurate sketch. Okay. So here you are. You're almost touching the line here at -5, and then you're going a little bit further down at each one of these intersections. And then by the time you get to 2, you're at 1/2. And at -1, you're all the way down to -1. And then as you, let's see, that would be half. So that would be -1/2, -1/3, -1/4, and -1/5. We'll say that right there. So 1, -1 would be here. Wait, hang on. Negative. I made that really. Let me get this better. -1, -1 is here. So I don't want to get that messed up. So then by the time we're at half, we're at -2. So it's right on 2. 3 as a third. 4 is a little bit closer, and then the 5th is almost touching, but it's not touching. So what this function is doing, and we'll dash it, is that it's getting really close to the asymptote, and then it's just going to get ever closer to it, but it's not actually going to ever touch it. So we kind of cut the graph off here, so we'll stop it here. Okay. And I dashed this one because what we're going to do is we're going to apply those shifts in the graph to graph this one. So what this is saying is this form right here, pulling the values. So we have our, for this one, it's saying, let's see, K, let's start with the K value here for +2. So for this graph, you have your vertical shift. So you're shifting up vertically 2 units. So where are we going to put this? We'll put it here. So we got a vertical. Is +2. And it's saying I have a horizontal shift here. The H is -1. So if your form is negative and your value is negative, that means that it's okay. So your horizontal shift is, let's see, it's -1. So what's happening is if it's negative, you're going in the positive direction because of the fact that you have to actually solve the 0. So you're going to go, so you're shifting to the right 1 unit. So instead of a negative, we'll say up. So this is up 2. We're going to say up 2 and right, R-I-G-H-T, right, +1. Okay. So you're going over to your table of values and recalling that your x-axis are these points. So this is going to be where you're going to apply your, you would apply your horizontal shift to your x-axis. So it's x component. So x value, I'll just put x values. That's the easiest thing to do. And again, I am just informally discussing this and working on the math. So, all right. And then the vertical shift is going to be your y values. Okay, so we'll put that off this side, y values. So if I were going to sketch my new table, we'll put our new table in here. Probably a better place to put that. Let me see if I can scoot it in here since we don't need the graph out that far. We can go ahead and just put that in there and put a little graph in there and stop it at 5. Maybe put the table in here. And I can just abbreviate that. This is HA. And then this should be fine for now. I can put it underneath. X/X is not equal H. Okay. So we've got our new table for our new function here that we're going to graph, and we're going to graph it by just shifting up the points. Like this is where a lot of my students would probably get upset with me if I presented to them, because they just want to know the one way, the quickest way to do it. They don't want to see all these alternatives. But this is not the only way to graph this function. It's just a way that I'm playing around with right now. Minor caveat. So we're going to go ahead and take all of the x values first. And we're just shifting them to the right 1 unit. So everything in the graph is going to go, if it's -5 and I go to the right 1 unit, I'm going to be at -4. And -4 would be -3, -3, let's see. And then we'll just shift them all down. So -2, -1. And so then I'm at -1 and I go right 1, hang on. That's going to put me at, let's see, we're at, I'm confused. -2 minus 1 is -1. -1 minus 1 is 0. And then 0 minus, I didn't put 0 in here, I skipped it because 0 was undefined. So we'll go ahead and skip it on this one too, so it doesn't throw me off. So -1/2 minus 1. -1/2 minus 1 is, or plus 1, hang on, plus 1, so that's +1/2. All right, so 1/2, and then -1/3 plus 1 is going to be +1/3. Wait, 2/3. It'll be 2/3. So I got lucky with this one because it was clean. But when you subtract 3/3 minus 1/3, that's 2/3. So, and then from 1/4, -1/4 plus 1, that's 3/4, +3/4. And then one more, sorry, you can't see what I'm writing. I'm just subtracting these. So -1/5 plus 5/5, which is just 1. Because all we're doing is shifting these points. That's going to give me 4/5, +4/5. Right? Yeah, 2/3, 3/4, and 4/5. Okay, and I put batteries in my calculator, but I don't know if they are, they weren't new batteries, so I don't know if they're fully charged or not. It was working 10 minutes ago, and it's giving me a low battery warning. So, but I do have my computer. I can, maybe, do I want to sketch the graph to look at it, or I want to just roll with it and assume it's right? All right, so we have to be careful because let's see, count the points. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 6, 7, 8, 9. I skipped one. Okay, so 5, 4, 3, 2, 1. Yeah. So 4, 3, 2, 1, and then 0 would be on here. Okay, so I can't skip 0. Let's see if I can crowd it in here. Because -1 minus 0 is on this new graph. And then that was still a -1/2, I think. Okay, -1/2 plus 1 is a +1/2. Okay, all right, I think I've got it. 2/3. It's a lot, it seems like a lot harder for me to think about just shifting the points, but it's a way that hopefully it's good for me to go through it. I would just rather plug into the new function and find the other points, find the points that way. But if this is how you prefer to do it, then it is an option. But we have to make sure that we've got all these points shifted because we're going to shift these as well. So the horizontal shift here is, let's see, what's it saying? The y values, we're going up 2 on all these points. So if you're at -1/5 and you go up 2, then see how we're adding fractions? Common denominator 5. And then 5 times 2 is 10. So this is going to be +9/5 for that first one. And then -3. So this one, we're going to go up 1. So we'll just go ahead and do it like this. -1/4 plus up 2 would be 8/4. So we'll go ahead and just convert that now. And so that's 7/4. Okay. Okay. And then we'll go ahead and let's see, -2, this next value, -1/3. So let's make equivalent fraction on that one. -1/3 up 2. So that's 6/3. So that's going to be 5/3. And then we've got -1/2 up 2. So that's 4 halves. So that's going to be 5 halves, positive 5 halves. And then, so that's 1, 2. So that's the fourth one is going to be -2. So that's a whole number now. So we're good. We're back to whole number land. So no more adding fractions. So -1 up 2 is going to put me at +1. -2 up 2 is going to put me at 0. -3 up 2 is at -1. -4 up 2 is -2. And -5 up 2 is -3. All right, so let's go ahead and shift this graph and see what happens. And then also it's telling us that our horizontal, so we list our HA was at 2, y equals 2, and our VA is at x equals +1. because of these values. So we've got, it said our horizontal asymptote was at K, which is 2. And then from the form, it said the vertical asymptote was when X cannot equal H. And H is positive 1 because the form is negative. So, all right. We'll go ahead and sketch these translated points with the new asymptotes, and then we'll probably go ahead and stop if there's no questions. Because I've already spent 30 minutes and I didn't even get to the function that I wanted to. So that's okay. I don't know if I'm just being slow or if this is kind of a painstaking process. But we're going to go ahead and sketch these new points. I wonder if I should go ahead and try to use a color for this. Let's see how good the green shows up. Let's see if we can get some green in here. All right, so we've got our new asymptotes. Let's begin by sketching those. And I put them here, y equals 2. And green's barely showing up, so let's pick a different color. Let's try blue. I have a purple here, you can see. I gotta get some more colors. No, purple looks like black still. Hang on, let me try something else. I thought I had a good blue in here. Use purple. These small markers. Look, what about pink? See if I can get pink. It's gonna be a rainbow here. Pink is more. I shouldn't even try. The standard red one. Okay, so we've got our asymptote for horizontal, and then our vertical one was here. And we've got -4, 9/5. 9/5. Let me just see if I can get this calculator to cooperate for 2 seconds. 9 divided by 5. Okay, that's 1.8. Positive 1.8. So we're almost at 2 for -4. So we'll put that point in right there. 7/4 is 1.75. So it looks like we're slightly further down here for -3 at -2. Slightly a little bit more than 1/2. So there would be 1/2. And then 5/2 is 2.5. So by the was that 5/2 or did I make a mistake here? There's no way that's 5/2. Well, it's 3/2. That's 3/2. I'll put it in red because I made a mistake. So that's 1.5 would be right about, let's see, a little bit. And that -1, we're right at 1/2. Positive 1/2. And then 0, we're at 1 right here. There's that intersection. And then 1/2 right here, we're at 0. So we're on the x-axis and y-axis here. And then we've got 2/3. So 2/3 is like right in here somewhere. It's a little bit closer, 3/4 and 4/5. So we're going to have to fit 3 points in there before we get to 1. But it's on the other side of 1/2. That's pretty cool. So let's go ahead and drop these points in here real quick. So 1/2 comma 0 was there. 2/3 comma is -1 all the way here. And then 3/4 we're at -2. and 4/5 we're at -3. All right, so we did it. So here is our transformed graph following that new asymptote to kind of show you that graph shifted. And because of this form, we didn't even have to know the algebra if we had all this information. So if you're taking a test and you're able to bring a card, I would just put this form on the card and then write these values in somewhere. You can, and it's a process, it's a method. It's but forms. It just depends on what you prefer. If you like the algebra and like to play around with it, the method that I showed you yesterday might be more effective. But I just thought it was interesting that I came across this form, so I thought I would go ahead and play around with it. Me personally, I would rather probably just evaluate the function. So if we do another rational function tomorrow, what I'll do is I will try to just go back to showing in its entirety from start to finish, plugging into the function that way and just pulling the values originally. Okay, so 36 minutes and I don't have any questions yet. So if nobody has a math problem for me to work, then I will probably call it good for today. But I will be back tomorrow, and this project that I'm working on, trying to get good at talking and presenting to the camera, it's really good for me to practice and discipline myself coming every day in front of my board and thinking about the math and working on it. So I will be back tomorrow again. That's between 6 and 7 p.m. Central Time. And again, thank you so much for watching, and I hope this helps. I'll see you next time. Bye.